Hello everyone. Today we are going to be finishing up our section 5.5 and 5.9 that's dealt with imaginary and complex numbers. The last part that we have to do here is what's below the line in your notes packet here. Okay, we're going to talk about the complex conjugate and then dividing our complex numbers. We kept this for a separate day because this is the part that usually gives people the most trouble, and it's helpful to feel really confident with the other stuff before we start to tackle this dividing business. So let's talk about this real quick with complex conjugates, and then we'll get into the dividing. So a complex conjugate is simply where we take a complex number, we keep the real parts equal. So real parts are equal, but we take that imaginary part, which remember is the BI portion. So imaginary parts are opposites. And so what we can use with that is, thus it can be said that the conjugate of A plus BI is simply keeping the A the same, but I switch the sign on the BI. So an A minus BI. So for example 6 here, we're going to find a bunch of conjugates of the following complex numbers. So I have that 4 plus 5i. Well, what I need to do is keep the 4 the same, because that's my A. My BI needs to switch, so that's a minus 5i. Part B is going to be 5 minus 7i, so I take that same thing, keep the 5 the same, but I switch the sign on the I and make it a plus 7i. In part C, I keep the negative 2, whatever that A is, we keep it the same, whether it's positive or negative doesn't matter, but the negative 3 needs to switch. Since it's negative, I'll make it positive. D is 6i. I don't have a number out front, so I don't have to worry about that. I just don't write a new one. And my 6i, because it has the I with it, needs to change signs, and we call it a negative 6i. And then finally down here for E, the 15 needs to go away as well. I need the conjugate of 15, which I don't have an I. This is really plus 0i at the end, which is going to give me 15. I could put a minus 0i, but that's still not really anything. So we just keep it as a 15. So those are conjugates. That part should be really straightforward. Conjugates by themselves are not actually very important. They're not something that we use a whole lot as far as just find the conjugate and it does something magical for us. Where they actually become very useful is when we start to multiply. And we actually did one of these. I made a little bit of a note about it when we were talking about it, but if you go to the multiplication section, which is example 4, and look at part C, if you look at 2 plus 9i and 2 minus 9i, those are conjugates of each other. And so when I end up multiplying them, my i's will cancel. I do get an I squared, but that becomes a negative 1, and I'm left with just a regular number. Now that's going to be super helpful for us when we start to talk about division, and let's talk about why that's going to be here. So if you remember, back when we talked about square roots in lesson 1.3, we said that the expressions in the simplest form cannot have square roots in the denominator. And we talked about how that's kind of an outdated thing, but it is something we still try to stick to, that we don't like square roots in the bottoms of fractions. So because that imaginary number, that I, represents a square root, it's the square root of negative 1, you must rationalize any denominator that includes an I. So as soon as I see 7 A, B, and C here all have i's in the denominator, I have to get those out of the bottom. Well, the way we do that, when we did it back with our square roots, is we used a process called rationalizing the denominator, which is where I multiplied by the bottom on top and bottom. The problem here is if I just multiply by what I have on top and bottom, I'm still going to end up with i's in my answer in the bottom. And so what we need is a way to cancel out the i's. The way we cancel out the i's is what we just showed you in that multiplication example, is we multiply the numerator and the denominator by the complex conjugate. And it is the complex conjugate of whatever we have in the bottom. Okay, and that's important because we're wanting to cancel out the bottom. You could technically multiply by the conjugate of the top as well, but that's just going to cancel out the top and you'll end up with i's still in the bottom. We don't want i's in the bottom, we want them on top. So what I need to do here for number 7 is I'm not actually going to divide. Divide is actually kind of a little trick here. What I'm really going to do is simplify and get that I out of the bottom. Okay, so let's see what this is going to look like. I need to multiply here by my complex conjugate of a 5i. Well, the complex conjugate is a negative 5i, and since I multiply it on the bottom, I have to multiply by the same thing on top, so that I'm not changing the value. We talked about this before. If I have the same thing on top and bottom, I'm really multiplying by 1. So I'm not changing the value here. I'm just changing what it's going to look like. So if we go ahead and simplify through, when I multiply two fractions, I go straight across. So when I multiply a 3 plus 10i times negative 5i, I'm going to put parentheses around everything here. What I'm really doing is I'm distributing this negative 5i into the 3 and the 10i. Well, negative 5i times 3 is going to be negative 15i. 10i times negative 5i is negative 50i squared. Then on the bottom here, I have a negative 5 times a 5 is negative 25. And my I times I is an I squared. So I still have i's in the bottom, but at least now there are these I squareds. Okay? And I actually know something about I squared. If you remember back to what we talked about in our last section, we said that I squared is the same thing as a negative 1. So I'm going to take in the top there and just replace the I squared with a negative 1, and I'll do the same thing on the bottom. When I do that, I'm then going to go ahead and multiply, and I am going to reorder the top here a little bit, because when I do negative 50 times negative 1, that becomes a positive 50, and since it's a regular number, I want to put it first, so this is in a plus bi form. So I have the 50 up top. I also still have my negative 15i. That hasn't gone away. And I'm dividing the whole thing by negative 25 times negative 1, which is a positive 25. Now, my I is gone. That was what I really wanted. I do not have my I in the bottom anymore, so I am technically closer to being simplified. But I do want to write this in a plus bi form. So to do that, I'm going to actually separate the bottom here. That 25 divides both the 50 and the 15i. So I'm going to divide each one separately. I am going to put kind of the minus in between now instead of with 15i, and you'll see why that is in just a second. I am going to try and divide these. If I can't divide them, I'll try and reduce. So 50 divided by 25 is 2. That one divides out. Then I'm going to have the minus. 15 over 25 doesn't divide evenly, but we can reduce this. 5 would go into both of them, so 5 goes into 15 3 times, and I tack on the I on the top. And then I also have 5 goes into 25 5 times. So what I end up with here is 2 minus 3 over 5i. And that I just put it in the top here, but you could also write it as 2 minus 3 over 5 with the I after. And sometimes that's more helpful because now you can clearly see I have the 2 as my A, and this negative 3/5 would be my B. So this is your A and your B that we have for A plus BI form. So that's the general idea of what we're doing. Yes, it is a lot of work. Yes, it's very easy to make some little mistakes through this, but if you take your time and go through it slowly, you should be able to divide these without any real major issues. But let's go ahead and try 2 more of these just so you have a few more examples as well. B is going to get a little bit more complicated because I don't have just an I on the bottom. I also have this 4 to deal with. But I still use the same process. I need the complex conjugate, so I'll keep the 4 the same, but the 2 needs to become a positive. Okay, and we'll do the same thing on the top. Well, now when I go to multiply, I'm not just going to be distributing because now I actually have 2 full pieces in the first one, 2 full pieces in the second one. Those are 2 binomials that are being multiplied, so this is where that foiling actually happens. So I'm going to do 2 times 4, which is 8, 2 times 2i, which is 4i, 4 times 8i, which is 32i, and 8i times 2i is a positive 16i squared. So I just FOILed across the whole top. Now I'm going to draw in my fraction bar, and I'm going to multiply all the way across the bottom as well. So I'll do 4 times 4 is 16. 4 times 2i is a positive 8i. Negative 2i times 4 is negative 8i. And negative 2i times positive 2i is a negative 4i squared. From there, I need to start to simplify. Okay? The first thing I usually simplify are my regular i's. So I end up with a 4. Plus 4i and 32i gives me 36i. While I'm at it, I am going to change my I squareds to a negative 1. Then I'll do the same thing on the bottom here. I have 16. My positive 8i and my negative 8i cancel. Okay, and that always needs to happen. If those i's do not go away, you multiplied by the wrong thing. Okay, then I'm going to have my minus 4 in times the negative 1 from the I squared. Okay. Then I can go ahead and simplify these negative 1s that are here. So this is going to be a positive 8 plus a negative 16 when I multiply by the negative 1. Well, that's going to leave me with a negative 8 plus 36i. And then on the bottom here, negative 4 times negative 1 is positive, so I'll add that. Gives me a 20. Well, again, I want to split this apart, so this is going to be a negative 8 over 20 plus 36i over 20. So in the first one here, 4 goes into both of those. It goes into 8 2 times, so that's a negative 2. Goes into 25 times. Plus, 4 goes into 36 9 times, so I'll put 9i there. And then 4 goes into 25 times again. Okay, so we have negative 2 over 5 plus 9 over 5i. And again, you can either put the I up top or put it after. Doesn't matter to me. Last one we'll talk about here is part C, which is negative 1 minus 8i all divided by 4i. So this is going to be more similar to the first one here, where I just need to multiply by the negative 4i on both top and bottom. When we do that, we'll distribute the negative 4i to the 1, which gives me negative 4i. Negative 4i times negative 8i is a positive, 32i squared. And then I would divide by negative 4 times 4, which is negative 16, times I squared. Okay, now, I'm going to show you, this is a lot of work to show, and so I'm going to show you how you can shorten it a little bit. I'm basically going to take out this step where I switch my I squareds to negative 1s. I'm going to kind of do that in my mind right now. I'm going to take these I squareds and really say, well, that's a negative 1, and this I squared here, that's really a negative 1. Well, then when I do that, I have a positive 32 times negative 1, which is negative 32. Then I have my minus 4i. On the bottom, I have a negative 1 times negative 16, which is a positive 16. Well, once again, I'm kind of finished there because I don't have the I in the bottom, but I do want to split this apart and divide it out. 16. All right, well, negative 32 divided by 16 is a negative 2, and negative 4i over 16 is actually going to reduce to 1/4, so this would be negative 1 over 4i. And in that one, I chose to just put the I at the end, just so you can see the difference there, but you could do it either way, either with the I in the numerator or next to it. You do not want to put the I back in the denominator because that was the whole point, was to get that out of there. Okay, the other thing I do want to just point out here, if you start to look at these answers, you are not going to be able to get these answers just by looking at what we start with. It's not like I magically take some numbers, do some adding and subtracting, and voila, there they are. You have to go through this whole process. Okay, and so that's one kind of really important part that you need to take away from the start, is it's not as simple as just dividing the 8 and the 4 or something like that. You got to go through that whole process. Okay, so that is going to finish it for this video right now, and we will see you for the next one.